Hi, I'm Professor Goins. In this video, I'm going to look at finding intercepts of functions. All right, so let's say we've got this graph of f of x, this red curve, and the x-intercept is the point that's on the x-axis that's also on the graph. The y-intercept is the point on the y-axis that's also on the graph. How can we find those? Well, I noticed that the x-intercept occurs where y is 0, or y equals 0 at that point, and I also know that for this y-intercept that occurs on the y-axis, which means that the x value is 0. Let's look at the summary down here. X-intercept, it's a point on the graph, so the point on the graph is of the form a comma 0. I know that the y value is 0, the x coordinate is what I have to solve for. In order to do that, I'm going to set y equal to 0 and solve for x because I know that this coordinate is 0, so this is the coordinate that I want to find. Said differently, we're going to set the function expression equal to 0 and solve that equation. So we'll do examples of that here in a moment. For the y-intercept, the point on the graph is of the form 0 comma b. That means I know that the x coordinate is 0, the y coordinate is what we need to find. The way we do that is by setting the x value equal to 0, because that's known. If it's on the y-axis, the x value must be 0. So I'll set x equal to 0 and I'll solve that for y. Said differently, I will evaluate the function at 0. X-intercepts, we solve an equation. Y-intercepts, we compute a function value. Let's look at a couple different types of functions here. I've got a linear function, a quadratic function, and a rational function. Let's find the intercepts of each one of those. For part A, right, for the y-intercept, let's look at the procedure. The y-intercept says to evaluate f of 0. That means I'm going to compute the function value. When the input is 0, that would give you 4 times 0 minus 10, which gives you negative 10. That tells me that the y-intercept would be at the point 0 comma negative 10. For the x-intercept for part B, or for part A, my procedure says to solve the equation, the function expression is equal to 0. That says I take the expression 4x minus 10 and set that equal to 0. Add 10 to both sides, 4x is equal to 10. Divide by 4, I get x is equal to 10 fourths. 10 fourths reduces, 10 and 4 are both even. That says I can write this as 2 times 5 divided by 2 times 2. Common factors cancel, so I can get rid of the 2 in the numerator and one of the 2's in the denominator, giving me the x coordinate of 5 halves. Therefore, the x-intercept for part A would consist of the point 5 halves, comma, 0. Before I do part B, just a quick mention that when we list y-intercepts, sometimes we'll list the ordered pair as 0 comma negative 10 because a y-intercept, as we can see, is a specific point. Points are listed as ordered pairs. However, another way that we'll do this is we'll say the y-intercept occurs at negative 10, x-intercept occurs at x equals 5 halves. So we might write it by just listing the number and the x or y coordinate, because for the y-intercept, we know that the other coordinate is 0. For the x-intercept, we know that the other coordinate is 0. So it is a slight abuse of notation where I just list the one number, even though it represents an ordered pair, but sometimes it's convenient to do that. So part B. Y-intercept for part B. We evaluate f of 0, 0 squared plus 3 times 0, which would give me 0. So the y-intercept is 0, or if you want to write it as an ordered pair, we know that for the y-intercept, we know that the x-coordinate is 0, and we just found that the y-intercept is 0 as well. So the y-intercept in this case occurs at the origin. X-intercept. X-intercepts are found by solving the function expression is equal to 0. That means I'm going to set x squared plus 3x equal to 0 and solve that corresponding equation. For solving a quadratic equation, we have lots of techniques. We could complete the square, we could factor it, we could use the quadratic formula. Usually we just kind of choose whatever is most convenient. Quadratic formula always works. Factoring will works, just sometimes the numbers don't work out super nice. Like with integers, sometimes they could be radicals or complex. But in this case, factoring is the quickest way to do it. Notice both of these have a factor of x, so I can write this as x times x plus 3 is equal to 0. And the idea is if I've got a product equal to 0, that means one of the factors must be 0. Therefore, either x is 0 or x plus 3 is 0. That would give me x is 0 or x plus 3 is 0. I'm not sure if that's on the screen. It's hard for me to tell, so I'll rewrite that over here. If I've got x times x plus 3 is 0, that means that either x equals 0 or x plus 3 is 0. That's the only way to multiply two things together to get 0. That gives me x equals 0 or negative 3 for my x-intercepts. Again, more technically, those are the x-coordinates of the x-intercepts, meaning your x-intercepts would be 0, 0, and negative 3, 0. But I'll just list the x values in this case. Okay, solution for C. Y-intercept. As we've seen numerous times, y-intercept occurs on the y-axis. That means that the x value is 0. So I'm looking at the function value at this point to give me the y value. Therefore, I compute f of 0, and this was the function right here for part C, so that would be 0 squared minus 4 over 0 squared plus 0, which gives me negative 4 divided by 0. So what does that mean? Well, if I have a 0 in the denominator that's undefined, what that tells me then is that this function has no y-intercepts. Okay, so there's no y-intercepts. Or no y-intercepts. All right, x-intercepts. Function expression is equal to 0, so function equals 0. That gives me x squared minus 4 over x squared plus x is equal to 0. What I then have is an expression that looks like a fraction equal to 0. The only way that a fraction can be 0 is if the numerator is 0. That means that this equation right here simplifies to x squared minus 4 equals 0, giving me another quadratic equation. The way we solve this quadratic equation over here is I factored out the common x. For this one right here, there's two different ways that we could solve it quickly. I could add the 4 to the other side and take the square root, but I want to factor it. This is a difference of perfect squares, x squared minus 4 squared, because of course 4 is 2 squared. And the difference of perfect squares always factors as the sum of the bases and the difference of the bases. X plus 2 times x minus 2 equals 0. That says that either this factor is 0 or this factor is 0, and that would give you x is equal to -2 or +2. Once again, those are the x coordinates of the x-intercepts. The x-intercepts are technically ordered pairs. However, it's frequent to simply just write the x values.